Alright, so in this video, I'm going to go over the review sheet for a probability unit for all those that love to hear my beautiful voice. Remember how I said that this video, or this review sheet is extremely similar to the test? Okay, so you feel good about this video, you should feel good tomorrow for the test. Okay? So, we're just going to go through each one, explain what to do, and I'm just going to kind of go through it kind of quickly, hopefully, for you. Alright, number one, Carl purchased 4 new shirts and 3 new pairs of pants. How many new outfits can he make with these items? Alright guys, that is literally just the fundamental counting principle. You take all the options that you have for one place and all the options for the other position and multiply them together. We have 4 shirts, we have 3 pairs of pants, multiply them together, we get the answer 12. Number 2 says, during training, a triathlete works on biking, swimming, and running times. How many ways can a triathlete choose the order of these activities in a training session? So how many different ways that I can arrange these 3 separate events? Now, there's 3 activities, 1, 2, 3, and you got to think about how many options you have starting left to right, okay? So in the first place, I can start off with biking, swimming, and running. That's 3 options. Whatever I pick there, I can't do in the second place. So if I pick biking here, then I have swimming and running left to choose from. That's 2 options. Then I only have 1 option left to choose from. Okay? That is 6. Another way to think about it, since we're talking about order, would just be would be 3, and we're arranging all of them. So 3p3, which is also 6. The answer is D. Okay. Number 7, evaluate. Number 3 and number 4, evaluate. This is just asking you to do permutation and combination in the calculator. Let's refresh ourselves how to do that. So you're going to go to, so you're first going to type 7, okay? Then you're going to go to math, PRB, and go for permutation. I believe that is number 2, okay? So you're going to go type that, and it's going to end up looking like NPR. So you're going to do 7 NPR, and then type 2, and hit enter. In this case, we get 42C. Same thing for number 4 with combination. Okay, in this case, we're going to type in 6, then we're going to go to math, we're going to type PRB, we're going to type number 3 in this case, which is NCR. Alright, oops, and then type in 2. And when you press enter, I end up getting 15B. Okay? So just remember how to do this in the calculator. I mean, you might have one that's simple as that on the test, but you also have some application. Okay? Alright, number 15. This is a very good problem. Star this problem. You'll see one just like this on the test. Bailey has 15 stems of flowers, 7 are tulips, and 8 are roses. If she randomly selects 5 flowers, what is the probability she selects 3 tulips and 2 roses? Okay, 5 flowers in no particular order at all. There is no order. Okay, if there is no order, if they're taken out in just some random group, okay, that implies that we're going to have to do probability with our combinations. Okay, our combinations. So how that's done is we got to do that NCR stuff. Okay, this is all combinations. So you got to think about, on top of my fraction is all of the number of successes. Okay, so since we have 2 separate successes here, tulips and roses, we need to have 2 parentheses on top. Alright, so for the first option, tulips, you got to think about all the ways I can take out groups of 3 tulips. Well, what NCR does is it tells us all those options. That would be, of the 7 tulips, choose 3. That's all the groups of 3 we can take out. And then for the roses, it's 8, choose 2. Okay, because all the total number of roses, this is all the ways we can take out groups of 2. That's what the calculator is doing for us. Then we divide that by all of our outcomes, which is all the ways to select 5 flowers. We have 15 total flowers, and this is all the ways you can choose 5. Okay. Type that into the calculator just like you see it, just like you're doing your combination commands from the last problem. I get a 0.33. Alright, number 6. In how many ways can the first 4 letters of the alphabet be arranged if each letter is used only once? Okay, that's A, B, C, D. Each letter can only be used once. Well, we got 1, 2, 3, 4 spaces. And it wants to know how many ways they can be arranged. Okay, well, if I can't reuse any of the letters, that means I have like 4 options for the first place, either A, B, C, or D. The next place, since I can't say I use A here for the first place, I can't use that letter anywhere else. So I have 3 options for the next one, then 2 options, then 1 option. Multiply those bad boys together, and I'm getting 4 factorial, which is 24. Okay, it is the same thing as 4 factorial or 4p. We're arranging the letters. Number 7 says there are 12 finalists in the figure skating competition. How many ways can gold, silver, and bronze medals be awarded? All right, again, we're talking about arranging these 3 different places. Anytime you're assigning any type of place, okay, like some type of like office or some type of medal or something like that, that's a permutation. Okay, the 12 finalists, I'm trying to arrange 3 of them. It's 12p3, where r is equal to 3, n is equal to 12. Okay. In this particular case, when I type it in, I'm getting 1320 different ways that can be done. 3, how many ways can you arrange the letters of the word calculus? Okay, I did this problem with some of y'all in class. If I'm talking about arranging those words, again, that is a permutation. That is a factorial. But because these letters are repeating, there is a special formula that we do in order to solve this. So you start by talking about all of the ways to arrange the letters, which in this case we have 8 letters, and we're trying to arrange them all. That's just 8 factorial. But you see, the letters that repeat, if I do 8 factorial, that is assuming that you switch the 2 U's. Okay, and if I switch the 2 U's, that's not anything different. So we have to divide out those repeating letters. So what you do is you look, you see, okay, there's 1 U, there's 2 repeating U's, so I do 2 factorial. All right, there's 2 repeating C's, so I do another 2 factorial. And finally, there's 2 repeating L's, so I do a 3rd factorial. Okay, and so you're dividing out those repeating letters that don't change anything. Okay? And when I do that in the calculator exactly as it's typed, if you want to put that in parentheses just to be sure, go ahead. I'm getting A 5040. All right, let's move on to 9. Mary has 15 colored pencils, 5 red, 8 green, and 2 yellow. As she is coloring, she randomly chooses 3 colored pencils. What is the probability that she selects 1 red and 1 yellow? Okay, this is just like number 5. She's taken these 3 out as a group. Okay, as a group, not one after the other. So that's combinations. So on top, we got to talk about all the possible ways, okay, that you can get 1 red and 1 yellow. Well, of the 5 red, I'm choosing groups of 1 red. Of the 2 yellow, I'm choosing 1 group of yellow. That's all the ways to get 1 red and 1 yellow. Then you divide by the total number of colored pencils, which in this case is 15, and then choose the total number of groups, which is choose 3. Okay. Bring that in the calculator, I get D 0.022. Number 10 is a good question. It says John is playing a game where he flips a coin. The object is to flip the coin and land on heads. He flips the coin 10 times, but only gets 4 heads. Okay. What is the theoretical probability and what is the experimental probability? Okay. For the theoretical is what you expect to happen. So like the ideal probability that you would expect to happen. Well, if for flipping a coin, getting heads is a 50-50 chance, 1 out of 2, 1/2. So the theoretical probability in this case, if you flip a coin 10 times, you would expect to get half of them as heads. 5 out of 10, or 1/2. That is the theoretical probability. That's what we always deal with. The experimental probability, well, that's what we actually get when we do the trials. In this case, we get heads not 5 out of 10, but 4 out of 10. That is my theoretical or my experimental probability, which is 2 out of 5 or 0.4. All right, number 11 says find the odds of an event occurring if the probability is 3 out of 11. Okay, so odds is success to failures. What we see in probability is the success. Okay, so that's my first number. To get my failures, you're going to take the bottom number and subtract the top number, because it's going to take your total outcomes and subtract your successes to be left with your failures. Okay, so that's 3 out of 8. So that is D. And vice versa, to find the probability of an event given the odds, well, again, odds is success to failures. What probability is successes divided by your total outcomes, or successes plus your failures, which in this case would be 9 divided by 9 plus 14, which in this case is D, 9 over 23. All right, number 13, the jar contains 10 purple marbles, 2 red marbles. If 2 marbles are chosen at random with no replacement, then what is the probability that 2 purple marbles are chosen? All right, if I'm saying no replacement, that's different than the previous problem when we're taking them out as a group. It means we're doing one after the other. Okay? Oh wait, no, I apologize. This is I'm switching this up with another problem. Sorry, I do apologize. In this case, we are taking 2 marbles out at the same time. Oh, sorry, let me say it again. So we are taking 2 marbles out at the same time. There is no indication, I apologize, that we are taking one after the other. Okay, there is no then statement, no or statement. Again, this is a combination. Okay, so think about it. We got 10 purple marbles, okay, and 2 are red marbles, and I'm wanting to figure out the probability of getting 2 purple marbles are chosen. Okay, so you're going to take the 10 purple marbles, and we're choosing 2, and we're going to divide by the total amount of marbles, which in this case is 12 marbles, choose 2. So we did the total number of successes and the total number of failures, and I'm getting C. All right, 14. A bag contains 6 cherry, 8 strawberry, and 9 grape-flavored candies. What is the probability of selecting a cherry, here's the key word, or a grape-flavored candy? So in the previous problems with probability, we're dealing with the combinations because we're taking them out in no particular order and we're taking them out as a group. Here with or statements, that means to add, because we're taking one probability or doing one event. I just want to know the probability of one or the other. That's just adding them together. So the probability of getting a cherry, well, that's just 6 cherries out of the total 23 pieces of candy, or whatever these things are. And then we're going to add the probability of getting a grape. Well, there's 9 grape out of 23, and that's just equivalent to 15 over 23, which is A. Now, number 15 is the same exact way, but you got to be careful with this one and the ones on the test. With or statements, you have to ask yourself if they're mutually exclusive. A die is rolled. What is the probability of rolling a 6 or a number greater than 4? Okay, so or means add. Well, the probability of rolling a 6 is 1 out of 6. The probability of rolling a number greater than 4 is 2 out of 6, because it can either be 5 or 6. But 6 is a number greater than 4. These two events are not mutually exclusive. You have to subtract by the probability of being both a 6 and a number greater than 4, which is 1 out of 6. And I'm left with 2 out of 6, or 1/3, which is answer choice D. Okay? I mean, think of it this way. Of all the options that you have 1, 2, 3, 4, 5, and 6 when rolling a die. If I'm talking about rolling a number that is a 6, which is that one, and a number greater than 4, well, that's this and this. You see how I circled 6 twice there. I got to subtract one of those out. Really, it's only a 2 out of 6 chance instead of a 3 out of 6 chance. Okay, so that answer choice is D. All right, number 16 and 17, I talked about these in class. These are given statements, okay? Anytime you ever see the keyword given, this is your indication to do this type of process. It says if one adult is randomly selected from these 1,000 adults, find the probability that the adult is a male, okay? So a male, given the person believes Republicans have better economic policies. Okay, So normally when I do these types of problems, I would do it out of 1,000 adults, my total. But what the given is doing is it's narrowing it down for me. It's telling me, hey, we're not looking at everybody. We're just looking at the Republicans. We're only looking at these numbers here, which is a total of 400 people. So instead of looking at 1,000, I'm looking at 400. Okay, well, I want to know the probability of out of these 400 that it's a male. So I'm looking at 230 males out of 400. All right, which in this case is 0.58 or A. Same thing with number 17. It says, in New York State, 48% of all teenagers own a skateboard, and 39% of teenagers own a skateboard and rollerblade. What is the probability that a teenager owns rollerblades given that the teenager owns a skateboard? There's my given statement. It's given that he owns a skateboard. So that's what my denominator needs to be, is that given probability. Well, the probability of owning a skateboard is given right here. It's 48%. And on top, we need to put the probability of both the fact that he owns a skateboard and owns rollerblades, okay, which is the other probability given to me. It's 0.39. So I do the probability of both divided by the probability of given, just like I did up here with these numbers. I did the probability of both male and Republican divided by all of the Republicans. Same exact process. In this case, I end up getting C 0.81. All right, these next few examples are dealing with binomials, CDF, and PDF. So binomial, CDF, and PDF. We're going to talk about all the different ways that you can see these problems and the keywords to look for. Okay? It says the bag contains 7 green marbles and 4 yellow marbles. The marble is drawn and then replaced, and this means that it's independent, which makes it binomial. And this is done 25 times. What is the probability that a yellow marble is drawn exactly 2 times? There is your key word. If you ever see exactly, you need to know to use PDF. All right, remember how this is done in the calculator. You're going to do second. You're going to go distribution, where the button says var sign. Okay? And you're going to go to option number, I guess it's number A in this case. It says binomial PDF. Okay? And it's going to require that you plug in 3 things. Okay? Your trials, your probability of success, and your X value. Okay, so let's identify those 3 things in the term of this problem. The trials is the number of times it's being done. Well, it says it's 25 times. The probability of success is the probability of getting a yellow marble. Well, the probability of getting a yellow marble, there's 4 yellow marbles out of a possible 11 marbles. 7 plus 4 is 11. That's my probability of success. Probability of getting a yellow marble. And the X value is just the number of times I want to get that yellow marble. In this case, 2 times. So plugging that into my binomial PDF option, I end up getting B. Okay. Now, number 19 says, what is the probability that a yellow marble is drawn at most 3 times? Okay, so there's my keyword, or my phrase. Instead of looking at exactly in PDF, this fact that we talked about inequality at most, that implies CDF. Okay. So the first step with CDF and inequalities is to write the inequality. In this case, if I say at most 3 times, I'm saying X is less than or equal to 3, because the very biggest it could be is 3. Now, this is a nice symbol. If we ever see that symbol, my calculator likes that symbol, and that's what we're going to type in for our X value into binomial CDF, which is option number B this time. Okay? So when I go to CDF option number B, I'm going to do trials. I'm going to do my probability of success and my X value. Oops. My trials is still 25. I'm still talking about a yellow marble, so my probability of success is still 4 out of 11. And my X value in this case is 3. CDF will do all the values up to 3. In this case, I am getting B. All right, now for number 20, this is the one that always tricks people up. Let's read it. What's the probability of getting a yellow marble at least 6 times. So there's an inequality, which means CDF again. All right, which means CDF. Now, the inequality that goes with that is x is greater than or equal to 6. But the calculator does not like that symbol. It only reads less than or equal to symbol. So what this is equivalent to is 1 minus the probability that x is less than or equal to 5. That's how you do it. All right, you do 1 less and then 1 less for the x value. And the number that's beside the less than or equal to symbol is the number you plug in for x. Okay. So in your calculator, what you're going to do is you're going to literally type in 1 subtract and then the binomial CDF, okay, with those 3 values in it. Okay, so it's going to be your trials is still 25. Your probability of success is still 4 out of 11. And your x value is going to be this number beside the less than or equal to symbol 5. When I end up doing all of that, I get D. A card is drawn from a standard deck of cards. What is the probability of drawing a king or a heart? Okay. Or means to add. Probability of getting a king is 4 out of 52. Okay. The probability of getting a heart is 13 out of 52. But those are not mutually exclusive. A king can also be a heart. So you have to subtract out the overlap. In this case, it's 1 over 52 is the probability of getting a king and a heart. All right, you don't want to count that more than once. So when I do that, I end up getting, let's see, 16 over 52, which is equivalent to B, 0.31. And then from a standard pack of 52 cards, a card is drawn at random. The trial is carried out 8 times. Trial, okay. Find the probability of drawing an ace at least 2 times. At least 2 times. There's your key phrase. I'm telling you an inequality. That implies that I am doing binomial CDF because of that inequality. So the first step is to write that inequality. That is, x is greater than or equal to 2. Unfortunately, my calculator does not like this symbol, okay? No likey, okay? So what I have to do is I have to rewrite that as 1 minus, okay? The probability x is going to be less than or equal to 1 less than 2 is 1, okay? So in my calculator, I am doing 1 subtract. Okay, 1 subtract the binomial CDF of my trials, which is in this case 8 times. My probability of success, which is the probability of getting an ace, which is 4 out of 52. And my x value, which I want to get an ace, let's see, in this case, that value there, 1 time. In this case, that comes out to be a 0.12. Alright. These next problems are a few free response questions, okay, so not like the multiple choice you'll see. So these are very similar problems that we're going to see in the test. It says a die is rolled 3 times. What is the probability of rolling 2 even numbers? Keyword here, then a 4. Then means multiply. If I'm talking about 3 times, I'm going to have 3 separate probabilities that I am multiplying. Okay? So the probability of getting an even number, that's 3 out of 6. The probability of getting an even number again is 3 out of 6. The probability of rolling a 4 is 1 out of 4. This ends up being 1 over 24 or 0.42. Or, sorry, 0.042. 24, there are 2 quarters, 3 dimes, 8 nickels in a purse. Suppose 3 coins are selected without replacement. What is the probability of selecting a dime, then a quarter, then a nickel? Then means multiply. So I have 3 coins I'm selecting. So 1, 2, 3 probabilities. All right, the probability of selecting, say, a dime. I got a 3 out of 13 chance of getting a dime because there's 13 coins total. All right, and then I'm not replacing that coin. Okay, I'm not replacing that coin. So now my denominator goes down to 12 coins. I want to know the probability of getting a quarter. Well, I have 2 quarters out of 12. Again, that denominator is going down 1 because I'm not replacing it. And I want to know the probability of getting a nickel, which I have an 8 out of 11 chance of doing that. That probability ends up being 4 over 143, or 0.028. Number 25, there are 2 quarters, 3 dimes, and 8 nickels in a purse. The same exact question as 25, but now 3 coins are selected with replacement. That means that I'm putting the coin back into the purse and my denominator is untouched. What is the probability of getting a dime, then a quarter, then a nickel? Again, that means to multiply. It's the same as number 24, it's just that the denominators are now staying the same. 3 out of 13, 2 out of 13, and 8 out of 13. Which I'm getting 48 over 2197, or 0.023. Okay. Number 26, a bag contains 30 marbles. There's 10 red, 12 blue, and 8 green. What is the probability of selecting a blue or a red marble? 2 events that are mutually exclusive. All you got to do is add. Or means to add. So we got the probability of getting a blue plus the probability of getting a red. All that is just a 12 out of 30 chance for blue and a 10 out of 30 chance for red. That's just equal to 22 over 30, or 0.733. Is the probability of drawing a queen or an ace mutually exclusive or inclusive? All right, remember, mutually exclusive means that they cannot be the same thing. Can a queen ever be an ace? Could they ever overlap? No. Okay, so that makes these exclusive. All right, a card can't be both queen and an ace. 2 different cards. All right, but number 28 is the probability of drawing a heart or a queen, or heart or king, mutually exclusive or inclusive. We got to ask yourself, can a king and be a heart? Can they overlap with each other? Yes, they can. That makes this inclusive. It's inclusive because a king can be a heart. Okay? 29 says, how many ways can you arrange the letters in the word beach? This goes back to the Mississippi problem, but look, none of the letters repeat. I'm talking about arranging these letters. All that is just arranging 1, 2, 3, 4, 5 different letters. That is, you can think of it as 1, 2, 3, 4, 5. That's 5 times 4 times 3 times 2 times 1. Or 5 factorial. Or 5p5. They're all the same thing. They all mean the same thing. Just arranging them all with no repetition. You're probably more used to seeing n factorial. That's just 120. Not bad. Number 30 says, given the number of trials and the probability of success, determine the probability indicated. Guys, this is like from your homework, those first few problems on your homework for the binomial unit. It just wants you to type those into the calculator. It's literally telling you the 3 things that you need to plug into binomial PDF. All right? It's telling you your trials, which is 14. It's telling your probability, which is 0.4. And it's telling your number of successes it wants to see, which is 4. And that's it. That's really it. When you type that in, you get 0.155. All right, last slide. It says, using a standard deck of cards, what is the probability that a card is a heart and a 5? That is a single probability. That is just a basic probability. It was talking about intersection. It wants to know all of the cards that are both heart and a 5. There is literally only 1 out of 52 cards in the deck of cards That is both a heart and a 5. Okay, and that's just the decimal 0.019. That's all that means. Okay. And then these last two, these are some good examples of expected value. Okay. This says a student has 5 pennies, 6 dimes, 2 quarters, and 1 silver dollar. What is the expected value of drawing a single coin out of your pocket? All right, that's the average. Remember, you've got to make a chart of all of your values and the probabilities of those values. Now, so let's think about all the options you have for pulling out a single coin. All right, you can get a penny, which is 0.01. You can get a dime, which is 0.10. You can get a quarter, which is 0.25. And you can also get, I made a mistake here when I first did this, I'm going to stick with it. I assumed that a silver dollar was worth 50 cents. I know that's very stupid, but I'm going to stick with it because that's what my work says. I guess really a silver dollar is worth 1, but I assumed it was 50 cents. Anyway, I'm going to leave it at that just for the sake of the problem. Anyway, those are all the outcomes you can have. The probabilities of those, well, you got 5 pennies out of a possible 14 amount of coins you could pick. You got 6 out of 14 options for a dime, 2 out of 14 options for a quarter, and 1 out of 14 options for a silver dollar. Okay. And remember, with expected value, all you have to do is multiply these together and add them up. Okay. So it looks something like this: 0.01 times 5/14 plus 0.10 times 6/14 plus 0.25 times 2/14 plus 0.5 times 1/14, which I'm getting to be 0.118. Okay. And the last expected value problem, the last one on the review sheet, is walking along the midway at the fair. You decide to play a game. You pay $4 to play. You have a 40% chance of winning a homework pass, black market value is $2, and a 10% chance of winning an advanced copy of the final, black market value $20. What is the expected value of the game? All right, again, we're going to list our outcomes and our probability of success. You got to think about this one a little bit more, okay? Let's talk about the first outcome. All right, let's think about the first option that we have. Okay, so first of all, it costs $4 to play. Now, the first thing I can get is the homework pass, okay? The homework pass. Let's think about the actual value that I'm winning when I do the homework pass. Yes, it is worth $2. But how much am I paying? I'm paying $4 to play. Okay, so really the money I'm gaining is negative $2. It's not a surprise, but I'm not really winning anything. The value is negative 2. All right, and it says that I have a 40% chance of winning that. Now, the other one I can get is the final, okay, the copy of the final. Now, the final is worth $20, okay, but remember, I'm paying 4 to play. So really, the money that I'm earning is $16, okay, and I have a 10% chance of winning that. Now, that counts for 50% of my outcomes. What about the other 50%? Well, how about I just lose? I don't get anything. Then I lose the $4 that I've paid to play. So there's your values. If I want to know the expected value, I'm going to multiply and add. So I'm going to do negative 2 times 0.40 plus 16 times 0.10 plus negative 4 times 0.50. And when I add those together, I get negative 1.2. Yay! All right. Good luck. Hopefully this helped a little bit. Kept it around 30 minutes. Yeah.